All right, ladies and gentlemen, we're going to be looking at two different topics today. We're going to be looking at sound intensity and then something called beat frequencies. Today, you're going to go through the slides in this presentation. You are going to take a hearing test, and then you are going to do the exit ticket, and then you're going to finish up that assignment from day 2 and 3. Today, you'll be doing the rest of that, which should be numbers 10 through 13. Okay, so taking a look at this hearing test. I would like you to do this hearing test. I will probably have you write down your range of hearing for your exit ticket. So make sure you do this. It's kind of a fun little video. The average human, well, I shouldn't say the average human, humans can range from 50 to 20,000 hertz for the frequency of their hearing. It all depends on how old you are. The older you get, the hair cells in your ears, they will degenerate. Those higher frequency hair cells are more on the outsides of your ears. So those are the ones that get more damage to them from hearing higher volume sounds and things like that. So that's why our high frequency or our high pitch hearing tends to go first. So and someone who is older might not be able to hear high frequency sounds as well. So this hearing test will kind of go through and it'll start off with a really high frequency and then it'll slowly drop it down. And then you can kind of pause the video and see when you initially hear it to see what your frequency range is. So we're going to start off with sound intensity here, being able to calculate sound intensity. Exit out of this. So sound intensity is basically how much energy is being carried through the medium. Intensity we represent with I, and it is power divided by area. Now, the area that we are going to use, we are going to consider it to be, if we're talking about a sound wave, we're just going to assume that a sound wave travels in all directions. So it would be like a spherical wave. So we will use the area of a sphere, 4 pi multiplied by radius squared. So that's always going to be our area. So we'll be taking power divided by area. Remember, power we measure in watts. Area is measured in meters squared, so that is going to be our unit. So we will have watts over meters squared for our unit. The human hearing range, like I said, it does depend on how old you are, but and it depends on a lot of other factors, but it's usually 50 to 20,000 hertz. And then anywhere from 1 times 10 to the negative 12th all the way up to 1 watt per meter squared. Now, the range that you are probably more used to when we're talking about intensity is not necessarily this intensity unit of watts per meter squared, but you are probably more familiar with something called the decibel scale. The decibel scale is something that we kind of use just because it has nicer numbers rather than using all these scientific notations of times 10 to the negative 12th or whatever that might be. But what this does is it kind of creates, it's a relative scale. So what it means is if I were to say that 0 decibels, that's basically, that's almost silent, or that is silence. And if we're talking about being near silence and we go up to 10 decibels, 10 decibels is going to be 10 times greater than near silence. And then I go to 20 decibels, and that's going to be 100 times greater than near silence. Then I go to 30 decibels. It would be 1,000 times greater than near silence. And this keeps going on. So 40 decibels would be 10,000 times greater. 50 would be 100,000 times greater than near silence. So it just keeps going up. by scales of 10. Okay, so let's take a look at a sound intensity example. So if we're talking about the sound level measured from 30 meters away from a jet plane at 140 decibels, or we'll call it 1 times 10 to the second watts per meter squared, what is the power created by the jet? Well, remember we said intensity is equal to power divided by area. Power, that is what we're looking for. All right, intensity, we have already, it gives us intensity as 1 times 10 to the second, or that would just be 100 watts per meter squared. And then we have area, which we said area we are going to use 4 pi r squared. And when you solve for that area, you can go ahead and plug that 30 meters into r there. I'll give you a second to solve for that. Hopefully you got 11,309 point, I have 734. Oops, that is not what I want. And that is meters squared for my area. Now I go ahead and I plug that into my plug that area into my equation over here, and I end up with power being equal to intensity times area. So I will just have 100 times 11,309.734. So essentially, we're just moving the decimal place. I apologize if you can hear my dog right now. He is starving for my attention. So I might have to go play with him a little bit after I make this video, right, buddy? So I end up with 1,130,973.4, and that is just going to be in watts, because remember we are solving for power. Okay. So there's an intensity example, and that's what a lot of your homework problems are going to be, is using that intensity equation. All right, the next thing we're going to look at is something called beats. Okay, beats is a phenomenon that occurs when you have two frequencies that are really, really close to one another. Okay, and you get this constructive and destructive interference, or this superposition of two sound waves over the top of one another. So if you go ahead and watch this video that I have here, this example video, this video does a really good job of explaining and showing examples of how beats occur and also the equation we use with it. So go ahead and watch that video right now, and then you can return to this video. All right, so hopefully you watched that video, and we had an equation introduced. That equation was the beat frequency is equal to the difference of two frequencies that are being played relatively close to one another. Now, I don't remember if the video talked about this or not, but this really only occurs if you have two frequencies that are probably within 10 hertz of each other, maybe 15. That might be stretching a little bit, but at a certain point you won't actually hear beats anymore. You'll just hear two different frequencies. You won't hear that kind of wah 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 noise anymore. Okay, so here's an example of a problem using beats. A tuning fork produces a steady 400 hertz tone when it is struck and held near a vibrating guitar string. 20 beats are counted in 5 seconds. So we want to know what is the possible frequencies of that guitar string. Well, we know the 400. That is going to be one of our frequencies that we know. Doesn't really matter which one you plug it in for. We'll just say that's frequency A. We don't know frequency B, And then my beat frequency, that isn't given to us directly, but they tell us that we have 20 beats every 5 seconds. Okay, so 20 beats every 5 seconds would give us a frequency of 4 hertz. So that is actually going to be our beat frequency is 4 hertz. So what are the possible frequencies produced by this guitar string? Since we have an absolute value, then we can just take plus and minus. My frequency of B is going to be either 404 hertz, or it could be 396 hertz. Okay. Why don't you guys go ahead and you can try this problem on your own. Similar problem. The only difference is here it gives you a closed organ pipe has a length of 2.4 meters. So keep in mind that you will have to use that frequency of a closed pipe equation in order to solve for that. And then so you'll be able to solve for the fundamental frequency, and then from there it tells you a 1.4 hertz beat note is heard. So what are the possible other frequencies? Okay, so try that one on your own. I will post the answers on there. And then last, I have just kind of this video that many of you have probably heard before, but this kind of has to deal with two different things. Well, I guess three different things. It has to deal with not only intensity, but it also deals with frequencies and matching frequencies. And it also deals with, because we match frequencies, it deals with this phenomenon called resonance, where an object basically absorbs energy due to vibrations. And this guy does a good job of explaining it. If any of you have ever watched Mythbusters, where they tried to break a wine glass using someone singing, or if you have ever taken your finger and made a wine glass sing by running your finger around the top of a wine glass, that has to do with resonance as well. So you can watch that video. You don't have to do anything with that video. It's just kind of a fun video to watch. And then finally, your assignment will be to complete the exit ticket. Remember, this is your attendance. Finish that day 2 and 3 assignment numbers 10 through 13. And like I said, in the exit ticket, I will have something about the hearing test. So make sure you go and you actually do that hearing test as well. If you have any questions, let me know. I hope you all have a great day.